Let's study types of database models. So, which are database models? DBM is database model. A database model defines the logical design and structure of database and defines how data will be stored, accessed, and updated in a database management system. While the rational model is the most widely used database model, there are other models too. Hierarchical model, network model, entity relationship model, relational model. So let's see hierarchical model. So this database model organizes data into tree-like structure with a single root to which all other data is linked. The hierarchy starts from root data and expands like a tree, adding child nodes to the parent nodes. In this model, a child node will only have a single parent node. This model efficiently describes many real-world app relationships like the index of a book, recipes, etc. In hierarchical model, data is organized into a tree-like structure with one one-to-many relationship between two different types of data. For example, one department can have many courses, many professors, and of course many students. So let's say we take an example of a college. College as a root, as a single root, which have two child nodes. Those are department and infrastructure. In department as a parent node, it has three child nodes. Those are course, teachers, and students. And the course is considered as a parent node, and it has two child nodes. Those are theory and labs. So this is a hierarchical model. So let's study network model. So this is an extension of hierarchical model. In this model, data is organized more like a graph, and are allowed to have more than one parent node. So in hierarchical model, we can see there is a single parent to every child. But here in network model, we can see that the child node may have more than one parent node. So this is an extension of hierarchical model. In this model, data is organized more like graph and are allowed to have more than one parent node. So in this database model, data is more related as more relationships are established in this database model. Also, as the data is more related, hence accessing the data is also easier and fast. The database models was used to map many data relationships. This was the most widely used database model before relational model was introduced. So here you can see A is the root node, B1 and B2 are the childs of A, whereas the parents of C1, C2 and C3. So C2 has parent nodes B1 and B2 both. So C2 has more than one parent node. So there is more than one relation, and there is a possibility of relationships increases over here. So we can access the data more easily and fastly. Then we have entity relationship model. In this database model, relationships are created by dividing the object of interest into an entity and its characteristics into attributes. So what we have done over here in this database model, relationships are created by dividing object of interest into an entity. So the object into an entity and its characteristic into attributes. So different entities are related to using relationships. So ER model are defined to represent the relationship into pictorial form to make it easier for different stakeholders to understand. This model is good to design database, which can then be turned into tables in the relational model explained below. So let's take an example. If we have to design a school database, then student will be an entity with attributes name, age, address, ID, etc. As address is generally complex, so it can be another entity with attributes street name, pin code, city, etc. And there will be a relationship between them. So relationships can also be of different types. To learn about ER diagrams in details, click on the link we provided to you. So here we have student. Student has student we consider as entity. So what are the attributes of student? ID, name, address, age, roll number, etc. Now consider an attribute of a student, that is address. So address as a now consider address as an entity. So its attributes are like street name, pin code, etc. So this is the this is this is known as the entity relationship, that is ER model. So let's study relational model. In this model, data is organized in two-dimensional tables. So what is the relational model? In this model, data is organized in two-dimensional tables, and the relationship is maintained by storing a common field. So what we have done in this model, data is organized in two-dimensional tables, and the relationship is maintained by storing a common field. Okay. So this model was introduced by E.F. Codd in 1970, and since then it has been the most widely used database model. In fact, we can say the only database model used around the world. So the basic structure of data in the relational model is tables. All the information related to particular type is stored in rows of that table. So hence tables are also known as relations in the relational model. In the coming tutorials, we will learn how to design tables, normalize them
First one
to
simple.
reduce
Java is easy to
data
learn and its
redundancy,
syntax is quite
and
simple,
how to
clean
use
and easy
capture
to
query
understand.
language
The
to access
confusing,
data from
ambiguous
tables.
concepts of C++ are either left out
Thank you.
in Java or they have been re-implemented in a cleaner way. For example, pointers, operator overloading are not there in Java but were an important part of C++. Second feature of Java, core Java is object oriented. In Java, everything is object, which has some data and behavior. Java can be easily extended as it is based on object model. Its third feature is it is robust. Java makes an effort to eliminate error-prone codes by emphasizing mainly on compile time error checking and runtime checking. But the main areas which Java improved were memory management and mishandle exceptions by introducing automatic garage, garbage collector and exception handling. It's a platform independent. The fourth feature of Java, core Java is platform independency. So it's a platform independent language, unlike other programming languages such as C, C++, etc., which are compiled into a platform specific machines. Java is guaranteed to be a write once, run anywhere language. On compilation, Java program is compiled into bytecode. This bytecode is platform independent and can be run on any machines. Plus, this bytecode format also provides security. Any machine with Java runtime environment can run Java programs. Java program first compiled into bytecode, bytecode then provided to the different operating systems such as Linux operating system, Windows operating system, or Mac operating system. Secure. The feature of Core Java is secure. Secure. It's a secure language. When it comes to security, Java is always the first choice. With Java secure features, it enables us to develop virus-free, temper-free system. Java program always runs in Java runtime environment with almost null interaction with system operating system. Hence, it is more secure. The sixth feature of Core Java is multi-threading. Java multi-threading feature makes it possible to write programs that can do many tasks simultaneously. Benefits of multi-threading is that it utilizes same memory and other resources to execute multiple threads at the same time, like while typing, grammatical errors uh, are checked along. Okay, so let's say discuss seventh feature of Core Java. Architectural neutral. Core Java compilers generate bytecodes which have nothing to do with a particular computer architecture. Hence, a Java program is easy to interpret on any machine. So let's discuss the fourth feature of Core Java. It's a portability. Java bytecode can be carried to any platform. No implementation dependent features. Everything related to storage is predefined. Example size of primitive data types and all. Let's see the ninth feature of Core Java, that's high performance. So Java is an interpreted language, so it will never be as fast as compiled language like C or C++, but Java enables high performance with the use of just-in-time compiler. The new features of Java 8 are those below mentioned are some of the core upgrades done as part of a Java 8 release. Just go through them quickly and we will explore them in details later. Enhance productivity by providing optional classes feature lambda expressions, streams, etc. ease of use. Improved polyglot programming. A polyglot is a program or script written in a form which is valid in multiple programming languages and it performs the same operation in multiple programming languages. So Java now supports such type of programming technique and it's improved security and performance. So Java input and output. Java input output tutorial. Java input output is used to process the input and produce the output. Java uses the concept of a stream to make input output operation fast. So the java.input-output, that is java.io package, contains all the classes required for input and output operations. So we can perform file handling in Java by Java input-output API. So let's discuss stream. A stream is a sequence of data. In Java, a stream is composed of bytes. It's called a stream because it is like a stream of water that continues to flow. In Java 3, in Java 3 streams are created for us automatically. So all the streams are attached with the console. One system.out, that's standard output stream, system.in, standard input stream, system.err, that is standard error stream. So let's see the code to print output and an error message to the console. So system.out println in double quotation, it's simple message. Any simple message we can put under this double quotation so that we can get an output, so that we can print an output. And system.err.println, println in double quotation error message. So let's see the code to get input from the console. Now when we take the input, we have to mention the data type. Here we have mentioned it as int, then we mention a variable that to which we have to give a value or input. So that variable is equal to system.in.read method. So returns ASCII code. So ASCII code of first character. So let's say if here we have taken the input, now system.out.println character, so we'll print the character. Okay, so now we will discuss out stream versus input, output stream versus input stream. So in explanation of output stream and input stream, classes are given below: output stream and input stream. So Java application uses an output stream to write data to a destination. It may be a file or an array or peripheral device or socket. So input stream, Java application uses an input stream to read data from a source. It may be a file, an array, peripheral device, or socket. Let's understand the working of Java outstream and input stream by a figure given on the screen. So let's see, here we can see a source that might be a file or console or socket. Oh, then from the source we are getting, in the diagram we are getting an input stream that is 1 0 1 0 1 0 1 0 1 0 1 0, that is 10 10 10 10. So we will read it. Java application, then it will process on the input and we will get an output stream as 10 10 10 10 10, right, and we will write it on the destination. So from source we read it as an input stream, and on Java application we will process on the input, then we will get the output stream and we will write that output stream on the destination. The destination might be a file, console, or a socket. So let's discuss output stream class. Output stream class is an abstract class. It is the superclass of all classes representing an output stream of bytes. An output stream accepts output bytes and sends them to some scene. Useful methods of output stream are method of one public void write in throws, input output exception, so is used to write a byte to the current output stream. So second one is public void write byte throws, input output exception is used to write exception is used to write an array of byte to the current output stream. Then second is public void flush throws, input output exception flushes the current output stream. Public void close throws, input output exception is used to close the current output stream. Output stream hierarchy. So output stream is consist of file output stream, byte array output stream. So output stream is divided into 5 streams, out of which one is file output stream, second one is byte array output stream, third one is filter output stream, the fourth one is piped output stream, and fifth one is object output stream. The filter output stream is further divided into 3 types. One is data output stream, buffer output stream, and print stream. Let's discuss about input stream class. Input stream class is also an abstract class. It is a superclass of all classes representing an input stream of bytes. So useful methods of input stream, those are input abstract, int read throws, input output exception. reach the next byte of data from the input stream, it returns 1 at the end of the file. Public int available throws input output exception returns as estimate of the number of bytes that can be read from the current input stream. Then 3 public void close throws input output exception is used to close the current input stream. Input stream hierarchy. Here we will see that input stream is also divided into five types. Those are file input stream, byte array input stream, filter input stream, piped input stream, and object input stream. In filter input stream, we can see there are three subclasses. Those are data input stream, buffered input stream, and pushback input stream. Okay. Now we will discuss the introduction to Java Virtual Machine. So what is JVM? So Java Virtual Machine is a machine that provides runtime environment to execute Java bytecode. The JVM doesn't understand Java typo. That's why you compile your dot star.java files to star.class files that contain the bytecodes understandable by JVM. Java Virtual Machine. Java Virtual Machine control execution of every Java program. So it enables features such as automated exception handling, garbage collection, collected heap. Then JVM architecture, Java Virtual Machine architecture. We can see uh, on the screen that is there is a class loader. Here we can see. Then there in runtime area we can see method area, heap, stack, program counter register, native method stack. Then we will see execution engine, native method interface, and native library. Now we will discuss one by one. So class loader loads the class for execution. Method area stores pre-class structure as constant pool. Heap is in which objects are allocated. So stack local variables and partial results are stored here. Each thread has private Java virtual machine stack created when the low thread is created. Then we will discuss program register. Program register holds the address of JVM instruction currently being executed. So in program register we can see the address of the currently executed instruction, JVM instruction, bytecode instruction. Okay, the native method stack, it contains all native use and application. Then executive engine. Execution engine controls the execute of instruction contained in the methods of the classes. Then method interface. Native method interface gives an interface between Java code and native code during execution. Native method libraries. Native libraries consist of files required for the execution of native code. Difference between JDK and JRE. So JRE is a Java runtime environment, provides the libraries. So it provides the libraries, the Java virtual machine, and other components to run applets and application written in the Java programming language. JRE does not contain tools and utilities such as compilers or debuggers for developing applets and applications. So Java runtime environment contains JVM, libraries plus other components. So let's discuss JDK. JDK is a Java development kit. It is a superset of JRE also and contains everything that is in JRE plus tools such as compilers and debuggers necessary for developing applets and applications. Now let's discuss setting Java environment. How to set a Java environment.